Hi all, my name is Mrinal and I am a student of Civil Engineering branch. I'm like many others preparing for GATE and other competitive examinations which are relevant for various engineering branches. So as you all are busy with your preparation or may have been busy with your preparation, I thought it would be helpful if I share my understanding of certain topics with you people in on short videos so that you guys can have a quick revision, or those who haven't covered can go through the topics and have a quick insight on it. So today in this short video I'll be covering the topic of eigenvalues, which comes under linear algebra, which is the topic relevant for all branches. So let's start. So here as you can see, I have taken a matrix, a 2 by 2 matrix, which is A having element 4, 2, 2, 4. So this can be any matrix. I've just taken this for us sake of simplicity, a square matrix of 2 by 2. And lambda is any scalar quantity. Scalar quantity, by scalar quantity we mean any the natural number, whole number, anything which is basically not a vector, which is expressed in a Cartesian coordinate. Any lambda is any scalar quantity, and I is the unit matrix which has its diagonal element as 1 1 1 and other elements are 0. Then if we write the equation of the form A minus lambda I, which is a simple subtraction of two matrices, and which will result in 4 minus lambda 2 into and 4 minus lambda as the elements. This is called the characteristic matrix of the given matrix A2, 2. So what is the characteristic matrix? The characteristic matrix is nothing but a matrix subtracted by a scalar multiplication of an identity matrix, and the resultant matrix which is obtained is called an identity matrix. It's called a characteristic matrix. Next, if we come down, we have a concept of characteristic polynomial. So once we have obtained the characteristic matrix as explained above, if we take the determinant of the matrix, as you all know how to take a determinant, that is multiplication of the principal diagonal subtracted the multiplication of the other diagonal. So here I get 4 minus lambda square minus 4. And if we express it in terms of a polynomial, which on expansion is getting 16 plus lambda square minus 8 lambda minus 4, and on simplification it gives this equation, which I'm putting it as equation 1. So equation 1 is nothing but the characteristic polynomial of the given matrix. So once again, what is characteristic polynomial? Characteristic polynomial is the determinant of the characteristic matrix. When expanded, we obtain a polynomial that is called a characteristic polynomial of the given matrix. So next is characteristic equation. So as you know, if we are equating anything to 0, that is called an equation. So same is in this case. Here, if we equate the characteristic polynomial, which is 16, the lambda square minus 8 lambda plus 12 to 0, we get an equation which is called a characteristic equation of the matrix A, which is of the order 2, 2. Next, we come to our concept of eigenvalues. So eigenvalues are nothing but the root of the characteristic equation. Here, as you can see, we have a characteristic equation which is of a degree 2, which is a quadratic equation. And if we take the roots, which the roots of root will come as 2 comma 6. So I will write it down. That roots 2 comma 6 of the characteristic equation, which is lambda square minus 8 lambda plus 12 equal to 0, are called as your eigenvalues, or the other name for it is the characteristic roots. So that means the root of the characteristic equation is the characteristic root of the A 2 by 2 matrix. So these are eigenvalues or the characteristic roots. So we will go through it once more. So as you can see, I have taken a matrix which is of the order 2 of the order 2 into 2, and it has element 4 2 2 4, and lambda is a scalar. I have taken as an identity matrix. Then once we are subtracting the product of lambda and the identity matrix from the matrix, we get a new matrix which is called a characteristic matrix of the given matrix A2 by 2. Then we have the concept of characteristic polynomial, which is the determinant of the characteristic matrix. As you see here, I have taken the determinant of the characteristic matrix, and it gives us the characteristic polynomial. Then we have the concept of characteristic equation, which is equating the characteristic polynomial to 0. And once we obtain the roots of the characteristic polynomial, as I have done here, the roots are 2 comma 6. These roots are nothing but the eigenvalues or the characteristic root of the given equation. So I hope you would have find this small lecture helpful, and do let me know if you want me to make more such short videos. If you are finding it helpful, I'll take up another topics of mathematics and also of civil engineering. And thank you guys for watching.